Hi thinkers, welcome to the Artificial Intelligence playlist on Thinkers Academy. In this tutorial, we are going to understand the A-star search algorithm. It is also known as the A-star pathfinding algorithm. We are going to study all the important points about this algorithm and how it is different from the other algorithms that we have studied in the AI playlist. So the first thing is I have drawn a graph here, as you can see. We can achieve this in programming using some two-dimensional arrays. Here you can see I have some vertices. The first vertex you need to focus on is this one, which is the starting node, and the second one is this goal state. Right, so we have a graph where we have a starting node and we have a goal state, and in between we have some other states as well, right? So we are actually visualizing some problem in a form of a state space representation. Now here you can see in blue color I have written some numbers here which represents the cost of reaching from this node to this node, right? So if you consider 3 is the cost from going from the starting node to the node number 2. And similarly we have other values here. So if we want to go from here to here, the cost is 9. In the green color, I have written the heuristic values. Heuristic values are basically a guessing value. It could be a smart guess, and we already know how we can calculate the heuristic value. We will also see that in this tutorial, in this later on. So here we have the heuristic values, which means that let's consider this heuristic value 12, which is of the node number 1. The heuristic value basically tells that from this node to the goal state, it is going to take a cost of 12, and this is actually only a guess value, right? This is not the actual value. From here, from the node number 1 to the goal state, we used some heuristics to calculate this guess, which we say as 12. So it is going to take this cost to reach from this node to this node, and similarly we have heuristic values for the other nodes as well. Alright, so now let's understand what is the A-star search algorithm. Now the A-star search algorithm is revolves around a very simple formula, which is F is equal to G plus H. Right, so it's a very simple formula where F is a value that we are going to use for understanding which is the best node to pick up, right? So here F determines best node to pick up, right? So the algorithm will use this value of F to determine which node is the best one to pick up, and then we have G and H. What is G here? G here is the actual cost, right, which I have marked in blue color, which you can see here in blue color, 4391. These are the actual cost. H is the heuristic value. So I'm going to write here that H is the heuristic value or the heuristic function, right? Basically a heuristic function calculates the heuristic value, so I'm just going to write here value. So what does this formula mean? How it is able to help us find out the best shortest path, right? So here the problem says that we want to find out the shortest path between S and G, which is the starting and the goal state. So let's start with the algorithm. In the first iteration, right, so I'm going to write this is the first iteration. We are on the starting state, which is this node. Now from here I have two nodes that I can visit. One is this one, and then we have 2 here. Now here what we are going to do is we are going to calculate F of S. F of S from S to 1, right, is going to be equal to 5 plus right? G is 5 here and H is 12. So the value of f of s of 1 is 17. So here I am just going to write here in red color 17, which is the value of f. Now let's calculate f s of 2. Right, so from s to 2, what is the value of f? G plus h. G is 3, h is 7, which is equal to 10. Now what the algorithm will do is, algorithm will compare fs1 and fs2, and as you can see clearly, fs of 2 is less than fs of 1. Now since the objective of the algorithm is to find the shortest path, the value of f, wherever it is less, we are going to pick up that node. Now here you can see fs of 2 has a lesser value, right? Since it has a lesser value, we are going to pick up the node number 2. So from here on, in the first iteration, the algorithm understands that the node number 2 has to be picked up. Now let's move on to the second step, or you can say the second iteration. Right, now we are on node number 2. Remember that node number 1 and node number 2, we can store them in 2 arrays. We can create 2 arrays. One can be an open array and one can be a closed array. Right, in the open one, I will have all the nodes which we are currently exploring. Right, so I'm just going to write here exploring nodes, and in the closed ones we are going to write the nodes which have been already explored. Right, so programmatically we can do it something like this. Moving on to the second iteration, what I just want to do is, now here I have picked this one, which is the second node. From here I can reach 4. Right, so what I am going to do is I am going to calculate f from 2 to 4. So I am going to write f to 4. What is the value of g here? From 2 to 4, the value of g is 4. But this g is not the actual cost from the node number 2 to node number 4. It is the value from the starting node to the node that we are actually trying to reach. So here g will not be 4, g will be 4 plus 3. What is 4 plus 3? 4 plus 3 is 7. So this actual cost is from the starting node, right? So I'm going to just write here s, so that it will be clear to you that we will have to calculate the cost from the starting node. So we have calculated 7 here. From the starting node to 4, it is 7. What is the heuristic value? Here you can see the heuristic value is 14. So I'm just going to add 14 here. So when you have added this, what is the value that you will get? You will get 21. F of 24 is 21. Now you can see here that now we will explore this also node, right? We will explore one node also. So here from I will calculate in the third iteration. Let's say I want to calculate f of 1 to 3. Right, from 1 to 3. So what is the value of g here? G here will be 11, right, which is 6 plus 5. And what is the value of heuristic here? In 3 we have 10, right? So here we have a clash. You can see that this also leads to a value of 21. Now what I am going to do here is, instead of making it 6, let's make this one as 5, or let's say I will write it as 4, so that I can explain you a very important concept here. So f1 of 3 will be 5 plus 4 is 9, and heuristic value is 10. Now this value will be equal to 19. Right, so I have made some changes so that I can explain you this important thing. In the first iteration, we got node 2 as a better, or you can say as a promising node. From here to here, which is fourth node, if I want to go to the fourth node, what is the value? The value is 21. Now let's see what is the value of f1 to 4. Right, so f1 to 4. We need to calculate the value of g. G is 7 plus 5, which is 12, plus 14. So let's change this value 7 to, I will change it to 1. Right, so here what is the value of g? 5 plus 1 is 6, plus what is the heuristic value? 14. What is the result? You can see the result is 20. Now see, there is a very important step here. If the algorithm will choose this node number 2, from starting node to fourth node, right, which is f to 4, we have a value of 21. But from the starting node to fourth node, if I will choose this path, the value is 20. So in this case, you can see that this, since we are actually trying to find out the shortest path, we will have to focus on the lesser value. Now since this was a more promising node, what we can do is we can, rather than traversing this path, we will traverse this path. Right, we will go to 1, then we will go to fourth node. Why? Because we calculate the values of f, and we found out that if we will choose 1 as the intermediate node between these roots, then we will get a very promising value of f. If we will choose the path which goes from s node to 2 and then 4, then the value is higher. Initially in the first iteration it was lesser, but we came to know that further if you will try to explore this node, you are actually getting the value of f as higher. So that's why we have changed the path. So 1 is going to be the more promising path. Now this is how we keep on doing this again and again until and unless we reach the goal state, right? So we will keep calculating, the algorithm will keep calculating the value of f, and it will keep understanding which node is more promising, and it actually knows what are the nodes that has been explored using this closed list, and it will keep exploring all the elements in the open list. Alright, so let's understand some important concepts here. Now let's say this is the path and we have now reached the optimal path. The first key point about this algorithm is that it is its completeness, right? So it means that there is a guarantee that you will reach from the starting node to the goal node. Then it is optimal. Why? Because we are actually using the whole actual cost from the starting node, and we are also using the heuristic function, which makes this algorithm a lot more optimal. Now the question is how to calculate the value of heuristic. Now heuristic function, we know that it is actually a guessing value, right? It is not the actual value. It is just a guess. How to make this guess? We have already seen that we can use a lot of things, like we can use Manhattan distance to get this heuristic value. We can use Euclidean distance. We can even use a diagonal distance, right? So we have some different formulas which we can use to calculate the heuristic function of each and every node, right? We cannot calculate the exact value of the heuristic, which is heuristic value. We know that it is the value of cost from one node to the goal state. So initially when we are in the problem space, we actually don't know what exactly is going to be the exact cost from this node to the goal state. So that's why we are making the guesses. If we can calculate the exact heuristic value, this whole algorithm will become more optimal. But obviously, if you want to calculate the exact value of the heuristic function, which means that the exact cost to reach from a node to the goal state, it is going to take a lot of time. It is going to increase the time complexity also. So basically that's all for this tutorial. Thanks for watching.